So good morning, everybody. Welcome to this session. Today, we're going to talk about the Nanotechnology Collaborative Graduate Program in the Faculty of Engineering. We're going to talk about the opportunities that you have to take a master or a PhD in just focus in nanotechnology. It is important to see the date in case that you're seeing this as a recording later. So today is May 7, 2024. So who are we? Number one, we have Dr. Kevin. He is an associate professor in the Department of Mechanical Mechatronics Engineering. Hopefully you will see him and meet him in person when you're here at Waterloo. He is an expert in nanotechnology, so he will explain all the details about that. We have Annette. She is administrative support in the nanotechnology graduate program. Also, she is there available to solve any question that you may have. And I am your host. I am Maria Sandoval, and I am the recruitment specialist in the Faculty of Engineering for graduate studies. All the information that we're going to share basically to apply to the Faculty of Engineering, it is here in this page. Maybe later when we finish the presentation, I can share my screen. You can scan this code. It is waterloo.ca/engineering/graduate students. So you will find, I invite you to go to this page, graduate students, and over there you will find all the details about the programs that we have, how to apply, the deadlines, funding, how to find a supervisor, how is to be here in the University of Waterloo, housing, like all the questions that you have are there. For this session, I invite you to go, I'm not sure if you can see this. I'm not sure if you can see in the bar in Zoom, then you can write your questions in the Q&A. And we will be happy to respond. Annette will be there in the chat, so you can leave your questions while we're doing the presentation. And then by the end as well, we're going to solve questions. So if you have any, just use the Q&A, and then we will be happy to answer your questions. The Faculty of Engineering is the largest engineering school in Canada. We have 6 departments and 2 schools. We have chemical engineering, civil and environmental engineering, electrical and computer engineering, mechanical mechatronics engineering, management science and engineering, and system design engineering. For this particular case in nanotechnology, you're looking for chemical engineering, electrical and computer engineering, and mechanical and mechatronics engineering. So you're not, we will explain you more in detail, but you're not applying to the Nano Institute or like to something directly to Nano. You need to apply to the department. You need to apply to the Faculty of Engineering, to one of the departments, to one of the programs that are inside of that department. So in this case, chemical engineering, electrical and computer engineering, mechanical and mechatronics engineering. And we have 2 schools. We have Conrad School of Entrepreneurship and Business and the School of Architecture. In the Faculty of Engineering, you will find different type of graduate programs. We have course-based and we have research-based. Okay, in the course-based, we have the Master of Engineering, and you will find it in all the departments. In management science, you will find the Master of Management Science. There are other type of programs, and this is course-based. So you're not gonna make any type of research. You don't need a supervisor. There is no funding, no guaranteed funding. So if you don't want to, if you're not interested in research or maybe not in a specific topic, you want to keep it more general, more short, 1 year, 1.5 years, then you're looking for a course-based program. In this case, we're going to focus in the research-based programs. So here we're talking about the Master of Applied Science and doctoral degree, PhD. In these type of programs, you're taking less courses, 4 to 5 courses, compared to the course base that is 8 to 9 courses, and you're going to have an original research and thesis. In this case, you see yourself developing research. You're working with a professor, going to a lab, and in this case, you're interested in nanotechnology. So this is the type of program that you're looking for, Master of Applied Science in one of the departments that I just mentioned. The Master of Applied Science, it takes 2 years to complete, and the PhD, it takes 4 years to complete. In those type of research-based programs in the Master of Applied and PhD, there is something that we call the collaborative programs. So what does it mean? For example, if you're taking a Master of Applied Science in Chemical Engineering, you will not be taking classes only with the students in chemical engineering of your master, but also with students in electrical and computer engineering, mechanical and mechatronics engineering, systems design engineering, if you are joining this program of nanotechnology. So that, of course, is a huge advantage because the perspective that you're going to have is going to be from different points of view. So probably your experience will be more rich. Yeah, and not only you will be studying with students from the Faculty of Engineering, but also in the Faculty of Science. So that's why it's called a collaborative program in nanotechnology. So when you're looking for programs, for example, you're looking in the Department of Chemical Engineering, the Master of Applied Science in Chemical Engineering, nanotechnology, or Electrical Computer Engineering, nanotechnology, Mechanical Mechatronics Engineering, nanotechnology, or systems design engineering, nanotechnology. We have other collaborative programs, water, quantum information, and aeronautics. In this case, we're going to talk about nano. As mentioned, so those are the departments participating in this collaborative program, the same list that we have here. In the same page that I mentioned at the beginning, you can find the page of each of them to find the details. So now, let's just talk about the program about nanotechnology.
Great, thanks, Maria. So yeah, I'm going to take it a step back now and sort of answer the question, what is nanotechnology in the first place? So nanotechnology involves manipulating matter at the atomic and molecular levels. So researchers and companies worldwide, they're developing materials and devices that are on the scale of 100 nanometers or less. So remember, a nanometer is a billionth of a meter. So as a reference point, a human hair is about 100 micrometers thick. So 100 nanometers thick is 1,000 times thinner than a human hair. That's the length scales that we're working at. So there's many examples of nanotechnology in everyday life now. So all of our modern electronics are based on thin films of materials that have dimensions of a few nanometers. Nanomaterials are showing up more frequently in cosmetics, so foundations and moisturizers. These can contain nanoparticles to improve texture and appearance. Nanomaterials are becoming very important in sporting goods to enhance the performance of the materials, so the strength and the flexibility and the weight of the materials. Also, nanoparticles and nanomaterials are showing up and more in clothing to provide clothing that's more durable, water resistant, antimicrobial, imparting all these sort of novel properties to clothing. And even things like sunscreen. So sunscreen can be made of metal oxide nanoparticles that absorb ultraviolet light while minimizing the health risks of the sunscreen itself. So nanotechnology is everywhere these days. So the next question is, well, then why might someone want to study nanotechnology? So there's a number of reasons, and I'll go through these on the next few slides. So first of all, nanotechnology is revolutionizing industries. Okay, so there's a few that are listed here, but this is not an exhaustive list. So in the healthcare space, nanotechnology is being used to develop targeted drug delivery, personalized medicine, early disease detection through things like breath monitoring devices. It's also revolutionizing the electronics industry, of course, by shrinking transistors down to smaller and smaller length scales to make faster and more efficient devices. Nanomaterials are ubiquitous in virtually every energy harvesting technology, so solar cells, batteries, fuel cells, so both energy generation and storage. And then more generally speaking, nanotechnology is revolutionizing just materials in all industries. So making materials that are more lightweight, that have novel properties like self-healing capabilities. These are all very exciting things going on in industry. You might also be interested just in developing very new materials, even if you don't have a particular industrial focus. So nanotechnology is enabling stronger, lighter, more durable materials. and materials with all sorts of unique properties. So self-cleaning surfaces or smart fabrics, nanofibers that can adjust to the temperature and moisture and light. These are all things that might interest you. You might also be interested in studying nanotechnology due to the positive environmental impact that you could have. All right, so nanotechnology is proving to be critical in many environmental technologies. So nanoparticles are becoming prevalent in water purification to remove pollutants and pathogens from water. Similarly, in air filtration, and also in remediation applications. So nanoparticles are being developed to aid in cleaning up oil spills and contaminated soil and removing pollutants from our built and natural environments. You may also just be interested in the thought of exploring and discovering new things, and technology is a great place to work with this in mind. So nanoscale phenomena, these defy classical physics in many cases. And this is sort of the quantum realm that people refer to. So you might be interested in studying quantum effects that may open up new scientific frontiers. There's certainly a huge push towards quantum research and quantum technology development in Canada right now. Other things like developing molecular machines, so tiny little machines that can assemble, repair, perform tasks at the molecular level. So you can imagine things like tiny nanoscopic little soft robots that can perform biological operations like drug delivery or IVF for fertility treatments. You may well be attracted to, and this was something that Maria already touched on, is the very interdisciplinary nature of nanotechnology. So it bridges different disciplines like physics, chemistry, biology, and engineering. So you get to work together and collaborate with people with different backgrounds and different viewpoints to solve complex challenges. So certainly in my lab, I'm in the mechanical and mechatronics engineering department, but we're very much an interdisciplinary lab. We have people in my lab with chemistry backgrounds, mechanical engineering backgrounds, electrical engineering backgrounds, material science backgrounds, and we need this collaborative approach to do exciting research. You may also be interested in pursuing nanotechnology because there are a lot of ethical considerations involved. Okay, so it does raise questions about the safety of new technologies, the privacy associated with new technologies that nanotechnology is enabling, potential unintended consequences of these new technologies. So lots of research or explore responsible development of nanotechnology, and this may excite you. Okay, so nanotechnology invites us to explore the infinitesimal, or the smallest particles hold immense potential for shaping our future. Next, I'm going to just give you a little bit more of a background on the program, the Collaborative Nano Program at the University of Waterloo. So it predates my presence here at the university. It's been around since 2008, and it was established as an interdepartmental and an interfaculty graduate collaborative program. All right, so what this does is it provides students with the opportunity to take courses and study alongside students from different departments and faculties. So you're not just always sitting in classes with other mechanical or chemical engineers. You're sitting in classes with people from outside your department and even outside your faculty. So the reason there was a number of objectives when the program was founded. First of all, there was a lack of structured interdisciplinary education and training opportunities for nanotechnology in Canada. And there was no graduate level program in Canada offering students an integrated multidisciplinary training program in this field. Okay, so the objective of this program is to offer you as students a stimulating educational environment spanning nanotechnology research and applications. Okay, so this required creating a leading educational training center involving both the faculties of engineering and science. So as I just mentioned, it does involve two different faculties and multiple departments in these faculties, both in engineering and science. And then it is also closely linked with a couple of institutes on campus. So the campus has about 25 institutes, and these are organizations that bring together researchers and academics and industry partners in particular fields to solve problems. Okay, so we have a Waterloo Institute for Nanotechnology on campus, and we also have the Institute for Quantum Computing. Okay, and both of these are heavily associated with the Collaborative Nano program. So you may be thinking sort of logistics, how will this make my program different as a prospective graduate student? So while you're completing your departmental program requirements, you'll simultaneously be completing requirements for the Collaborative Nano program. So what this involves is you need to take an introductory nanotechnology course called Nano 600. You will attend a number of nanotechnology seminars that are hosted on campus. So this is when we bring in external researchers or industry representatives to give talks to our students and professors. And you also get to choose one or more courses from a list of collaborative program courses. So these are listed here. So ideally what you'll do is you'll take your Nano 600 core Introduction to Nanotechnology course. Then you'll also pick one of these Nano 600 other courses listed in the table that might be very applicable to your research project. And then you may also have to take one or two other courses to meet your department requirement. All right, so I've already mentioned WIN. So this is the Waterloo Institute for Nanotechnology that's closely affiliated with supports the graduate nano program. So WIN hosts over 40 research seminars a year. So it's an opportunity to connect with and hear from leading nanotechnology experts from around the world. They also have pitches and demos, networking events, an opportunity to go out and pitch ideas about nanotechnology and hear ideas from other people on campus about their work and things they might be interested in. And WIN also provides a lot of opportunities for students to present posters at workshops and symposiums and conferences that they host here on campus. There's also the Waterloo Institute for Nanotechnology Graduate Student Society. Okay, so as a member of the Collaborative Nano program, you could be a member of this society that represents about 150 graduate students. And the society provides events, networking events, and social events for the student body that are studying nano technology at the University of Waterloo. So there's a number of strengths at the University of Waterloo in the nanotechnology field that I can point out. I won't read all the details here, but there's a lot of very exciting research going on in nanomaterials. So certainly my lab is a nanomaterials focused lab. We develop new types of nanoparticles and thin film coatings, and we apply them mainly to health and energy applications. So photovoltaic solar cells, gas sensors for sensing harmful pollutants, photothermal therapy for cancer therapy. So lots of new exciting nanomaterials that we synthesize and study. There's a lot of excellent work going on nanoelectronics, design and fabrication, next generation of our next generation of electronic devices. Lots of different nano instruments and devices, so different types of sensors and different types of tools for characterizing nanomaterials are all being developed at the University of Waterloo. And then lots of exciting research on nanobiosystems. So again, I mentioned the example of soft robots for drug delivery and fertility treatments and things like that. So the interface between biology and nanotechnology is very exciting, and there's a lot of wonderful research going on here at the university in that field. And you have access to a lot of leading edge facilities. We're very fortunate at the University of Waterloo to have the Mike and Ophelia Lazaridis Quantum Nano Center. So this is a state-of-the-art nanotechnology research facility with lots of characterization tools, like very expensive electron microscopes, clean rooms, state-of-the-art clean rooms for making novel nanoelectronic devices and sensors and things like that. And then in addition to the Quantum Nano Center, there's a number of other shared facilities on the University of Waterloo campus that you can access as a grad student. for your research. So shared labs like the Giga to Nanoelectronics Center, the Quantum Nanofab facility I've already mentioned, the Watt Lab, this is the Waterloo Advanced Technology Lab. All these labs here are other ones that you have the opportunity to access on campus. So in addition to the research lab and environment provided by your supervisor, research supervisor on campus, you also have the opportunity to access really exciting cutting edge equipment at various facilities on campus. And then for the details of how to get into the University of Waterloo, I'm going to hand it back over to Maria. Who's going to need to unmute herself, I think.
Thank you. Thank you. So there are many reasons why you should get involved in the nanotechnology field. It is important as well to remember that you don't apply to an institute or like to something specific about nanotechnology. You need to apply to the faculty. In this case, we're talking about the Faculty of Engineering or to the Faculty of Science if you're interested in that faculty. And then inside the Faculty of Engineering, then you apply to one of the departments that we mentioned. Each department is responsible for their own admission policies and program requirements. So I will share here now the list where you can see, just give me 1 second. I'm going to share here the list of programs, and then you're going to visit the academic calendar, and that's where you're going to find the admission requirements by program. Sharing that now here in the chat. Okay, so the admission requirements can change according to the program that you are applying to the department that you are applying to, even if it's chemical engineering, mechanical mechatronics systems, or electrical and computer engineering. In this case, on top of the admission requirements, you need to find a supervisor. You don't need a supervisor to apply, but to be accepted, you need a supervisor because you're going to work with that supervisor. So it is important that you start to identify with who you would like to work with. We already saw that there are multiple fields related to nanotechnology, so you need to identify your own research and how it is aligned with the research of one of the professors at the university. So you have two options. You can look by department. So each department, it has the list of the professors and the research that they are doing, or also you can find it by research area. Again, when you're visiting, maybe in a bit, I will share the screen. When you visit our graduate page, you will find both of them. Well, I think I already mentioned this, and we have already a full webinar with the advice about how to approach a supervisor. That's one of the challenges at the beginning, because maybe like Kevin, for example, he's running research. He has the students, so he has the classes. Like there are many things going on with a professor. So maybe the professor, you made an excellent email, but maybe the professor missed it, and then you anyways can apply and mention, for example, Professor Kevin, and then in your application process, after you fulfill the admission requirements, then they can flag your application like, Kevin, there is this person that would like to work with you, and that's how also the process starts. There are different ways how each department does it, so it is important that as well you define to which department you would like to apply to. Something as well to remember are the application deadlines. It is the same for all the faculty. So for graduate studies, we have 3 intakes. We have an intake in September, another one in January, and another one in May. So fall, winter, and spring. And the deadline to apply is 6 months before the beginning of the classes. So for example, now we're talking, if you want to start in January, then the deadline is June of this year. If you want to start next year in May, then the deadline is October. Or if you want to start in fall 2025, then the deadline is February 2025. So 6 months before. I will share my screen now, and I will show you the details. The application is 100% online. You don't need to submit any physical document. You just have to apply through the portal. The tuition is also based in your domestic residency status or international immigration status. So it can be domestic, domestic out of province, or international. In the same page, graduates, I sound repetitive, but everything is there. In our graduate page, you can find the tuition according to you. It is important to remember that because you are applying to a research-based program, then you receive minimum funding guaranteed. That's why also you need a professor, because that's where mainly these resources are coming from. So if you're applying to a Master of Applied Science, you are going to study 2 years, 6 terms. So you're going to receive $18,000 per year. If you're applying for the PhD, this is 12 terms, 4 years, then you're going to receive $30,000 per year. And this is tax-free. So those are great news for you as a student to receive this minimum support. On top of the minimum funding as well, there are several opportunities. This is only minimum funding guaranteed, but also you can apply for TAs that will add more to the budget. Maybe also you can apply to different awards, scholarships that we have. It can be because of your excellent grades. It can be because of any research that you're doing. It can be because of like different conditions that you have that you can apply to some of them. Some of the awards you don't need to apply. It's just when you make the application, you indicate your status, or some of them you do need to apply. So it is important that you explore this. And again, it is in the same page. One of them that Annette will talk about it in a second. There are specific scholarships for Nano. So of course, we encourage you to see the details. Annette will explain that in a second. But I just want to share with you the screen with the page. So this is our graduate students page. Here you can find all the path to apply. So first, of course, to define the program, to create a budget. So here you can see everything about tuition, living expenses. Here, the full information about funding, scholarships, and awards, the admission information. So you're looking, remember, for specific departments and the specific programs. If you are international student as well, you can find like all the grade equivalences, for example, to Canada, and the English requirements if your degree is not Canadian or from an English-speaking country. It is important that you get ready with all the documents that you need to present, so you apply on time. So transcripts, references, the supplementary information form, your resume, your English language proficiency, and GRE. Some of the departments, they need this exam. And about how to find a supervisor, this is where you see, just read all the information that we have here, even just the advice about how to contact the supervisor. And you have these 2 options, so you can look by departments. So for example, like let's look in the Department of Mechanical Mechatronics. So we go here to Material Engineering and Processing, for example, and here you will find the list of professors. I'm just going to take it as an example. The first one that came here. So we have Professor Elliott. You need to read, of course, the details about their publications and their research areas. And then you can see here if they are accepting students or not. So this is one option that you have, looking by department, or also you can look by research area. So for example, here you type nano, and then the professors involved in that area will come as well. I'm just going to take the first example. So we have here a hub, and then we will see the profile of the professor. And there you go. You find all the details. It is important that you really align your interests with the research that the professor is doing. That's mainly the key to succeed. And here as well, everything about funding, scholarships, and awards, everything that I just mentioned now with the database of awards, here it is. Okay. So now we can continue with the awards that are specific for nano. Okay, Annette. Annette?
Yep,
Yeah.
I'm here. There are, I just want to make a note, there are a couple of questions in the Q&A and we will get to those. I just want to make sure that we have the best answer for your queries. So please check back. We'll definitely be answering those questions as we go along. So the Waterloo Institute of Nanotechnology, the institute that we're associated with, they also offer fellowships. They're $10,000 fellowships. And those are available to any student, or students are considered if their supervisor is involved in nanotechnology, and also if the student is doing, of course, research in the area of nanotechnology. And there is also the WIN Velocity Scholarship Program in Entrepreneurship. And the idea behind that is bringing the research or the results of the research to commercialization, or becoming an entrepreneur with the research that you have created at the University of Waterloo. And there's also the WIN Graduate Student Mobility Fund. And that award is approved for students can apply for up to $250 from the WIN grad student program. And there are up to 10 grants per year for that program as well. So one of the most unique things about the University of Waterloo and the research that you do at the University of Waterloo is the fact that 100% of the intellectual property that you've created, or whatever your creation is through your research or your discoveries through your research, are 100% owned by you. And that is very unique to the University of Waterloo. And I don't believe there's another university in Canada, and I'm not sure about North America, that offers that opportunity to you. So that's in itself is a really good reason to study at Waterloo. The University of Waterloo is not just a place for education. Entrepreneurship is also a big attraction to the University of Waterloo, and that is you taking whatever you have created, potentially taking it to market, and building a business once you've graduated from the University of Waterloo. And the University of Waterloo and the community of Waterloo as a whole help with what is called the entrepreneurial ecosystem at the University of Waterloo. And as I said, this is very unique to the University of Waterloo. So research and discoveries by students in the labs and facilities, excuse me, can often result in a marketable product. And since the students since you own your creation, as I've discussed with the 100% intellectual property agreement that we have, the University of Waterloo and the region of Waterloo support and the development of the commercialization through things like the Velocity Incubator, where you can go, students have an opportunity to go and develop, for example, a prototype of their product, and they learn about marketing their products. And then there's also the Accelerator Center that is part of our ecosystem, and they provide mentorship at the Accelerator Center about how the business side, the entrepreneurial side of marketing any products, or and commercialization for with industry experts and by industry experts. And all of this, I guess, is how you would define what we call the ecosystem. It's supporting learning, discovery and creation, and to commercialization and entrepreneurship. And the University of Waterloo is not just about your academic experience. We also are very invested in your wellness as an individual. There are a lot of wellness initiatives for mental health supports. And one of the biggest things and biggest ways that you can support and enhance your experience at the University of Waterloo is through the many different clubs. There's 200 plus clubs at the university. There are 120 programs that offer at the undergraduate level co-op. There are 100 different student exchange programs that students at the university participate in. Most are at the undergraduate level, but there are always opportunities for exchange and learning opportunities elsewhere in the world, perhaps in a full-time off-campus research term or the like that may be arranged with your supervisor. And there are 34 varsity teams. So there are many recreational clubs and intramural sporting activities offered. So Waterloo's not just about your academic experience, but also your entire experience at the University of Waterloo.
So that's the information that we have ready for you today. Now we will go with the questions that we have here in the chat. Ricardo is asking, thanks for the informative talk. Do you know any interesting problems for nanotechnology that are somewhat related to computer science? I'm from computer science, and I would like to know if there are certain aspects in which nanotechnology overlaps with computer science.
Yeah, I'm happy to take that one, Ria. So the short answer, Ricardo, is yes, absolutely. So of course, artificial intelligence is very big these days, but it's been applied in the nanotechnology field for a number of years now. It's been very important. So people are using AI tools for lots of things in the nanospace. So as a couple examples, I had a PhD student who was focused on developing neural networks to help characterize nanomaterials using the characterization tools. So he was, marrying computer science and our nanomaterials characterization. People are using artificial intelligence tools for materials discovery. So using these machine learning algorithms to sort of survey and study and invent new nanomaterials. In a lot of our nanotechnology research, we're generating lots of data. So I study sensors, and we're producing all sorts of sensing data, and we're employing machine learning tools to interpret that data and better understand what we're observing with these nanotechnologies. And so often we're collaborating with a computer scientist who has more expertise in that space. So lots of work in the AI applications to nanotechnology, and then other things as well. So, sort of next generation computing architectures. There's lots of research on neuromorphic computing. So neuromorphic computing will allow us to adopt new types of computer architectures where we have the computer processing and the computer memory integrated together, right? And part of that is developing the devices and the hardware, which is sort of a nanotechnology challenge. But then, of course, you need to have computer scientists involved to sort of understand how we can use this new type of hardware to tackle computational tasks and make sure we're designing it properly and working together to make better computing architectures. So lots of exciting research there too.
That's why it's so interdisciplinary, this field. Christian is asking, to apply, must I have some research related to nanotechnology?
I'm happy to take that one too. So the short answer is no. Again, this is, nanotechnology is very interdisciplinary, so it requires people with all sorts of backgrounds. So to give you an example, like in my lab, we're often, one of our things that we focus on is designing and building equipment for nanomanufacturing, so for making very thin film coatings. Okay, so I'm commonly taking graduate students who have very traditional mechanical engineering or mechatronic engineering backgrounds that can come in and apply their skill set in mechanical engineering to the mechanical design of this equipment to solve a nanotechnology problem. Okay, so it is very interdisciplinary and collaborative. We need people with different backgrounds to come in and apply those skill sets to nanotechnology problems.
Someone anonymous is asking, concerned teachers, master, I'm assuming, MASC, quantum computing and electronic, how many classes are online? I'm not sure if you know the answer for that, Kevin.
Yeah, like I don't know specifically for the
Yeah.
quantum computing program, but I can say for the engineering department or faculty, so electrical engineering and computer engineering, like everything's back to in person. Courses, that's required. Everyone's back to in person. It does depend a bit on the instructor. So there are different types of delivery. So some people do follow, I do for one of my graduate courses, a blended approach. So they've got some asynchronous work to do, prepare, and then they come to class, and we have a 1.5 hour class each week, which is very focused on sort of interactive learning activities based on the asynchronous material that they covered themselves. So you do have some of these blended approaches, but at least in the Faculty of Engineering, courses are all back in person.
Back in person. What is the schedule for part-time and full-time studies? I think to answer that question, probably you will have to see, again, depends on the program and the department, if they are offering full-time or part-time studies. And Christian also is asking, do you offer any line of research in nanotechnology in food?
That's an excellent question. So I sort of have some tangential. I personally have some tangential work in this space. So I traditionally have done thin film coatings for electronic devices, so photovoltaic solar cells, LEDs, things like that. But then we discovered there was a huge need for our thin film coatings for sustainable food packaging. So my lab's actually spun off a company called Infinite that's based here in Waterloo, and we're developing nanotechnology barrier coatings for sustainable food packaging. We're also interested in gas sensing for food spoilage. So this is a big problem. There's a huge amount of food spoilage in Canada and food waste. So developing low-cost nanotechnology-enabled gas sensors that can detect biogenic amine gases. So these are gases that get emitted from food when they spoil, so we can monitor food. Now, directly incorporating nanomaterials into the foods themselves, there may be other researchers that are looking at additives to foods and things like that. I can't say off the top of my head, but hopefully the couple examples I've given you have shown that nanotechnology is very interdisciplinary and can solve challenges in many fields. So we do have, I personally have a couple of projects in the food area.
You'd like to find a supervisor and a specific, it takes a little bit of work, but you have to just use the tools that we provide for you. So look by department, look one by one, just having this, the first one, chemical engineering, for example. Then you go and you find nanotechnology, then you see the professors, what they are doing, because of course there are more than 400 professors at the university. So of course it's like not easy, but it's something that you just have to do. Look for department or also go here and look by research area until you find the professors that align with your interest. Someone else here is asking, employment opportunities. What are the employment opportunities, I would say, after studying, after getting a nano degree?
Yeah, so I can comment on that. So I noticed it does say while studying too. So
Yeah,
while studying is one question, and that's so typically you can take on TA positions to be a teaching assistant on campus. Another thing is keep in mind a lot of the research projects professors have are industrial collaborations. So some of the time you'll be working on a research project where you actually are collaborating with industry and getting industry exposure through your research project. Then after studying, again, since nanotechnology is so interdisciplinary, you get people going off into all sorts of different areas. So, I can comment for my my group and where people have gone. I've had people go, unfortunately, we get some going to the States inevitably and going to work for Apple and Teslas and things like that. Some go into academia and follow a postdoctoral route and then try and become a professor. There's also opportunities in Canada in the technology sector. So I had someone go into the photovoltaic industry, someone into the medical robot industry, someone else in the flexible electronics industry. So there are opportunities to find jobs that are very closely related to your research projects. But I think the nanotechnology program, and it's due to its collaborative nature, it gives you a very broad view of the field, and you're able to apply your skill set in different industries as well.
As Shad is asking, what are the aerospace applications of nanotechnology, and how does Waterloo research nanotechnology for aerospace applications?
Yeah, that's a good question. So I don't explicitly, well, that's not true. I do. So you should also be aware that the Waterloo, one of its other institutes is the Institute for Sustainable Aviation, called WISA. And actually, I'm mainly a nanotechnology researcher, but I do have a collaborative project with WISA where we were looking at developing gas sensors for sustainable aircraft cabins. Okay, so that we're applying our sort of nanotechnology research to a problem in the sustainable aircraft industry. But there's certainly other applications in aerospace, like in the sustainable space. A big thing is SAF. So this is sustainable aerospace fuels. Okay, so this is a chemical engineering discipline that is very nanotechnology related. And there's a lot of work going on to develop new types of fuels for sustainable aircraft. Lightweighting of materials using nanomaterials is critical, of course, for aerospace too. There's stuff going on there.
Here we have another question as well about research. And I think I would just mention it again. Like, I know it's hard because the university is huge and there are many things happening at the university. So you do need to go and find the research area by departments and to read the profile of the professors or to use the option to. Sashan is asking, I was wondering what's a good way to get familiar with some of the opportunities available as for thesis subjects, or is it determined after you are accepted with a professor? For example, if I'm interested in quantum computing overall, but not sure about what kind of research is done, how could I find out more about what the research will be like given that doing a thesis will be so specific?
It's a very good question. So, the first step is to look at the different professors and get a sense of the broad fields. So Maria's shown the tools you can use to go through professors and see the areas that interest you. But then if you want to drill down to sort of what sort of thesis project might you end up with, then you sort of have to get into discussions with the specific professors. And that's pretty typical. So when I'm recruiting students, I'll have an interview with them. I'll be asking them about their interests, and they'll often ask me about what projects are available. So you can have that discussion once you've narrowed it down to a couple professors and you're having you've got some discussion going with them. That's the point at which you can commonly ask, what kind of projects are you going to have available, and get a better sense of specifically what you might be doing. Because it's a very fair point. This is 2 or 4 years of your life, so you want to know what you're going to do with it, right?
By the way, okay, we have like 10 minutes left. Let's see. How important are grades for a master in research, and what will be a good way to improve the application if grades are not the best? So here, maybe I can help with that answer. So you have to see here, future students over here, you need to fulfill the admission requirements. The University of Waterloo is highly competitive. That's why we have this reputation as well. So you do need to have all the requirements to apply. what can you do? So the minimum grades that we have, like you need to have them. What you can do to improve a little bit your profile is to work well in the references. That's very important, the reference that you can get. And when you fill the supplementary information form, then also explain all the information we will take the information that you are providing to us. So it is important that you work on this. I don't know if Kevin, maybe you have something else to add to that. Oh, we're good.
Yeah, all I can say is from my experience, there's the minimum grade requirements, which ideally you meet, but there is a bit of a, maybe I'm not supposed to say this, there's a bit of a fuzzy boundary where some exceptions can be made if you otherwise have a very strong application. So doing the things that Maria said, make sure you've got great references, that you've got a great application package outside of the grades, then you might put yourself in a position to get considered.
Like why Kevin wants to work with you. That's mainly the issue, not the issue, the thing to explain. Adam is asking, thanks for the presentation. I'm looking for a PhD research opportunity in thin films and collagens, as well as droplet surface interactions. Any opportunities?
So yep, Adam, there's lots of people here doing research in that field. So I, for example, I'm one who does thin film coatings. So the best thing to do is, go onto the websites that Maria's shown you, search for the keywords that are of interest to you to find the professors and sort of have a closer look at them to see which ones you might want to reach out to. But like I do thin film coatings. There's Professor Shushanta Mitra who does a lot of research on surface droplet interactions. There's really cutting edge research there. So there's certainly people here, world leaders in those fields.
Perfect. Yeah, this is a very common question, but it is there. You have to start from that point. Arfa Araf is writing us from Bangladesh. I completed undergrad in naval architecture and marine engineering. Now I'm studying master's in mechanical engineering. Can I apply in PhD program of nanotechnology? Maybe. Or we will have to see probably the best approach, because of course, any of us, we don't make admissions. So I would say the best advice for you is to see the type of program that you're interested in. Like, is it chemical engineering? Is it electrical computer engineering? Is it mechanical mechatronics or system design engineering? And then you can contact a grad coordinator, and they also can guide you better with specific questions about your degrees. So probably that will be the best approach according to the department that you're interested in. Flora is asking, is it possible to visit research units of interest in the process of making a decision towards a program for those who live in Waterloo?
So and Marie might be able to comment further, but certainly there's sort of two answers to this. Sometimes the university organizes events to bring in and recruit grad students and bring them to campus. So the Waterloo Institute for Nanotechnology, the last couple of years, they've held a summer school where they will actually provide some funding to help bring prospective graduate students to campus to go on tours, see labs, hear talks, things like that. So there's university organized opportunities like that for sure. And then the other way is once you've connected with a professor and you have a potential professor in mind, then often it's, if you're in discussions of joining that professor's research lab, I very commonly encourage the students, if they're located nearby, to come to the lab and see it firsthand and meet me in person. But that will be specific to the professor.
I was also going to mention that Maria has organized a graduate recruitment fair as well on June 5th, Maria. Wednesday, June 5th, from 2 to 5 p.m. in the E7 building, and there will be department booths. We will have a booth there, the collaborative program. Oh, she's bringing it up. Great minds think alike. I'll leave it to you, Maria, then to talk about that, because that might be an opportunity as well.
Yes, Flora. So if any of you, and including you, Flora, are if you're here in Waterloo, on Wednesday, June 5th, we're going to have the Engineering Graduate Studies Fair here in A7. That's Engineering 7 at Waterloo, 2 to 5 p.m. You will have the program coordinators, professors, explaining all the details about the programs. So this could be a good opportunity for you to come. Also, if you're here in Waterloo, you can, again, in our grad page, you see here Waterloo campus, and then you can have a tour of the full faculty. You can attend a campus tour that is organized by the faculty. There is not one specific for graduate studies, but you can attend the general one. So this is another way how you can find about us. Of course, it's an advantage that you are already here. Okay, other questions we have. Anonymous attendees asking, what do I need to apply direct from bachelor to PhD? So my advice for you, anonymous attendee, is to contact a program coordinator. It all depends on your profile exactly. Like, why do you think you already have the skills to apply directly to the PhD without the master? So that's like a discussion that you really need to have with them. First, you need to define the department so they can answer you the question. And I'm going to leave for you here the list of program coordinators. Here it is. There you are. And we have, I did, Nasrul is asking, I did MEng from Western in 2010. And then I worked for airlines as head of engineering. Now I'm interested to pursue a PhD in nano composites, aircraft structural materials. How can I proceed? Then probably a good approach, Narsul. Soon we're going to send the recording of the session, and also you're going to see it in our page. We explain all details about how to apply to one of the programs. You need to find first the department of your interest. Let me bring our page here. So probably that was the entire objective of this session. So probably you will have to see the recording of the session to apply. And Christian, the last question that we can have, I'm interested in applying artificial intelligence in nanotechnology. In which department can I find supervisors?
Yeah, that's a good question. Christian, you're not going to like the answer. Right now, it's effectively any department. I think AI has been becoming such a ubiquitous tool that I'm sure there's supervisors in all of the departments that are applying AI to the research. So probably what you need to do is think about what are the applications that interest you. Okay, and then go to the website and use those keywords, AI gas sensing or AI lightweighting of materials or AI material discovery, and sort of look for fields where, the application fields that are of interest, where there's some professors applying artificial intelligence. But I'm sure there's
Many.
supervisors in every department now.
Many. I just type it here, like artificial intelligence, and then all of them.
And Kevin, would it be fair to say that when looking for a prospective supervisor, looking for specifically the area of interest, it may not include the word nanotechnology, may also bring up a match for a supervisor who is working in the area of nanotechnology, but more specifically, as the example that was presented, artificial intelligence, for example.
Yeah, absolutely. So, there might be people, there's a question on nanocomposites. There might be people studying composites, and the materials have length scales on the scale of nanometers, but they don't explicitly specify nanocomposites as a keyword. They just say composites. So right. There will be artificial intelligence applied to many things, and nano may not be a keyword. It may have a nano component, but you're not necessarily you don't have to limit yourself to supervisors with that nano keyword.
And can I ask you a question? I'm going to put you on the spot here. What when a student reaches out to you, what's sort of a hook that would grab your attention for a potential student that you would be interested in supervising? Just as a last comment, sort of.
Yeah, so maybe I'll preface my answer with just a comment to applying students is never be discouraged if a professor is not interested or able to take you on, because this is often determined by factors outside your control. Okay, so we as professors applying for research funding through grants, depending how much funding we get, that dictates how many students we can take. And a lot of the time, we may not simply have funding in place to take another student on. So you might be the greatest candidate in the world and be the perfect fit, but we just may literally not have the dollars to pay you. So never be discouraged if a supervisor is not doesn't engage with you to have further discussions. But in terms of attracting a supervisor and making yourself stand out, so a few comments. First of all, keep your emails to them fairly brief. Supervisors are busy. If they see a 3-paragraph, 2-page email, they are not going to have time to read it all. Okay, so keep it clear and to the point. Number one, make it clear that you've done some research and that your interests are aligned with them. So you can explicitly say what your area of research interest is. They will see that that aligns with what they do. Okay, this person has looked into my profile. They know I'm a suitable supervisor for them. That's one thing. Next thing is strong academic standing. So if you ranked near the top of your class or won any scholarships or awards, don't be modest. Point that out in the email and say I was ranked second of 63 students in my graduating class at so-and-so university. And then in addition to grades, emphasize any other experience you have that you think might make you well suited as a graduate student. So any other previous research you did, either in co-ops or in a previous master's degree. Any extracurricular skills based on, maybe you have some industry experience and worked in industry, and that would be applicable to your research. Emphasize those points as well. So cover, your area of interest, your grades, and sort of experience outside of grades as sort of concisely as possible.
Fantastic. Thank you.
Perfect. Okay, so we are good. Thank you so much for both of you, Professor Kevin and Annette, for your time. I'm sure after this session, all the participants, they have a better understanding about how to apply for the collaborative program in nanotechnology in the Faculty of Engineering. We made the session to guide you because we know it's a lot of information. So hopefully we can wait to receive your application and hopefully to see you all soon in campus. So you can meet in person, you can meet us in person. Thank you all for your time.
Thanks.
See you then next time. Bye-bye.
Bye.